Okay, I have pretty much few slides, no, not many. So just to give a small background, we kind of started to do the caching almost 4 years ago between Caltech and UCSD. Two sites are pretty much close to each other. Both of them have 100 gig uplink. And it's kind of first step potentially to merge all the namespace between two sites. As currently we have more or less 2 petabytes of raw space in cache. It grew from 200 terabytes to 2 petabytes. Why we do that? I mean, mainly it's to save the disk space. On so-called sites, it used to be replica 2. On caches, it's replica 1. So on both sides, we are kind of gaining by factor of 4. It's kind of changing with erasure coding whenever sites are using erasure coding on the main storage. And it's only 30% overhead as comparison. And another reason is to increase the efficiency of the jobs running remotely and reading data remotely. I have few slides in the back, and we are repeating the same tests. And of course, what is the next, and define the data lake model. So just small background how CMS jobs are opening data. So whenever CMS jobs lands on worker node, it reads the site local configuration. And in site local config, we have mainly 2 rules. The first one is usually open file locally, and another one go to Fermilab redirector. If local file is not found, it will go to Fermilab redirector, and we'll try to get the location where the data is and open that file remotely. So what we do with cache is we kind of changing the site local configuration, and we are appending the few rules in beginning, so that if any logical file name starts with, for example, store MC run to miniod sim, redirect to local x cache redirector. If not, do the usual stuff, try to open file locally from the storage CMS mount point. If file is not found, go back to Fermilab redirector. After running cache for quite some time, more or less 4 years, I think we need to learn from each other what we do and how we proceed in future. I think what we do on CMS, it's mainly cache on demand. So whenever job lands, job can pre-cache any data on the cache. As far as I know, please correct me if I'm wrong, but Atlas does more on the in advance model, where Rucio stores the data on the caches. So I would be happy to learn more what are the good and bad things. And of course, there are many other things what we are considering to do. And we have more caches coming up in the US. How do we control them? Should we consider any new technologies like NDN? And how we do the space accounting? So I think that's all what I had to just to start the discussion.
Okay, do you guys want to?
I think it'd be good to have a discussion here for about 5 minutes or so,
Okay,
because the topics switch more to tapes next. So does anyone have any follow on from these points?
Yeah, I guess I was curious about maybe what Atlas's model is, where these caches are filled with or filled by a Rucio. Could maybe describe a little bit of how that looks?
I think for Atlas, the caching we do are X caches based on XRT technology. We don't really use the caching mechanism and that Rucio describes in its documentation.
yeah, I guess at some level, our tier 2s are all caches. They just have a pretty long lifetime.
We do have a set of queues, panda queues, which are basically program to look for specific replicas from Rucio, still redirecting the reads through Xcache, but choosing data that are informed by the workloads that are anticipated to go there. So the idea was that if you didn't have any, if you had no sort of intelligence there in terms of what data would be going to which cache, then it would sort of not be optimized because of the the different workloads, just using all different kinds of data would just be cycling over all the time. So it sort of has been built into the workload management system and Rucio, independent of the caching technology itself. Should have invited Ilya here to give us a lecture on BP, but it's called BP. But yeah.
But cache churn is an issue, right? And getting a big enough working set size in the cache for the activity at a site is one of the important considerations.
Right, which is what he was trying to minimize. Yep.
Yes, Steve has his hand up.
Oh, yeah. I was just wondering, as far as caching is concerned, how people that are doing that with Rucio, with the very, if you have a big churn in your cache, does Rucio keep up to that okay?
Who's the question directed to?
Sorry, Stephen, can you repeat that question? Yeah.
Yeah. So I'm just wondering how well Rucio is operating with the cache in which things turn over a lot.
I think it's actually working pretty well. Yeah, again, we should get a presentation on this, but this is there. I mean, I think that also at the I think Ilya reports on this a little bit at the Xcache meeting, but yeah, I think it's the set of VP queues that he has, and the idea behind these queues was partly to address the issue where you don't have a lot of pre-placed Rucio stage data, right? You just have a cache in front of the system.
Well, I mean, I know there was also a presentation in Reach Up about this last year, and they claim they have it working, but it's just a little bit surprising to me that they do. So interesting. Thank you.
Eustace, the SoCal cache is sort of the scale of about a petabyte, isn't it?
Let me go. I think I had it on slide. No, so at Caltech we have 2 petabytes at USSD 240 and in ESNet 40 terabytes.
Okay, thank you.